This is not a dream.
Today we get to look at this equation here. It's a linear equation with one variable, which is x, one variable. And the twist is that we're looking at the equal sign as a balancing point. This here is the center of the Rubik's Cube, and it acts as a balancing point for all the other objects in the cube. So what many people do not know is that an equation is a system with a balancing point, that an equal sign. It allows things to move around it, just like the Rubik's Cube does. So the Rubik's Cube has a center of 3 axes interconnected. An equal sign is a central point, an equilibrium point that an axis sort of passes through. It allows different things to move about it. So over here, this equation here tells us that 2/3, right, of 4 less than 5 times a certain number gives us 1. 2/3 of 4 less than 5 times a certain number gives us 1. Then what that means is that, well, we can solve this knowing that 2/3 equal 1. Then that will mean that twice of this bracket will also be 3. If 2/3 is 1, right? Yeah, if I have twice of this instead of 2/3, it will no longer be 1, right? It will be 3. How so? So we multiply each part by 3. Now guys, you see that we have multiplied this side by 3 and multiplied that side, multiplied this side by 3. So by doing this, we have tripled the whole system. Now if you triple a system of 2/3, right, of anything, right, what happens is that the denominators will cancel out. So it's as if you now have 3 over 3 now. Yes, so this is 3 over 3 times 2. And this is a legally perfect move in mathematics. So remember, this equilibrium system has no change. Just because you have tripled it, right, it remains the same. So let's go straight and then simplify this. Obviously, 1 times 3 will always be 3. This, we are going to get rid of this. So when we flip this away. So what we have here is another system that we have tripled. So you realize that by tripling 2/3, we get double. And on this side, it makes that 3 times because there was only 1 here. So this indicates the tripling. So what we have, this now becomes simply 3 now. Okay, so we're safe with this. So we have 2 here. What happens to the system if I try to remove this 2 away from here? Right? That's what we want to find out. So let's see. Reducing this by, or removing 2 from the bracket side, it means it's no longer double of the bracket. So it's just 1 of this bracket. It makes this side of the equilibrium system tend to less than sign. Because it was double of this that gave me 3. So if I now have reduced it to 1, it means that this left hand side is now less than 3 times that we had of the right side, right? So what do we do to make it equal? So it means that we will have to divide this side by 2, since it's double of this that we have taken away, leaving only 1 whole value of it. We now have to divide this by 2 so that it makes up for the double and leave 1 of the doubles. So that would be as a result of dividing this side by 2, after removing the 2 from here and dividing, that resulted in dividing this side by 2, we now have still an equal system, right? Yes. So we have 5 or 4 less than 5 times of the number, and there's nothing operating this object outside here, so it's better we remove this from here so that we have this simplified form, right? Yeah.
Oh my god.
We have added 4 to both sides and this side has blown to 0. In other words, the negative 4, that's how we say it, has gone to the other side of the equal sign. So this equilibrium system is still equal. So let me bring it here. So another way of writing 4 is 8 over 2. 8 divided by 2. This is a very simple way of going around. So by doing this, what this means is that we created the same denominators. And when you have the same denominators, what can happen is that there's a fusion. So this fusion has caused the same denominator to join the 2, as you can see. So now we have just 3 plus 8, and that gives us what? 11. Yeah, and this is 11 on 2, as you can see. So over here, the relationship between the two here is multiplication, like so. So multiplication 5 times x is what gives you 11 over 2. So if 5 times of x is what is responsible for this, then 1 time of x would cause this to be divided by 5 to get the same value. So we divide both sides by 5, and this is what we have. So we have two division signs, sorry. There's a minor division sign and a major division sign. This is we're going to apply the reciprocal rule here to be able to get our answer. This side is 5 on 5 times x is another way of writing this. Another way to think about 5 denominator is that denominator also is divided by 1. All whole numbers are divided by 1. So now we have a system of 3 divisions, with a major division in the middle, minor division up here, minor division here. So to be able to solve this, we change the middle one into a multiplication sign. Well, when that happens, it means that this will reciprocate. It will go up, and this will come down. The reverse of it will happen, and this sign will now be multiplication. Yep. So this is how reciprocation works. And because we are multiplying, the numerators will multiply and the denominators will multiply separately to give us each their answer. This is now 11 over 10, as we can see on the side. But as for this, we simply flip it off.